Alrighty, so I'm going to wrap up 2-3 today. The example 5 here, this one says determine positive and negative intervals. So it's actually going to tie in a skill that we've worked with back in chapter 1 into what we're doing right now. So the idea here is, it says identify the interval on which this function is positive. So to do that, we really need to know what this graph looks like. So instead of using the graphing calculator, which, I'll be honest, you could, but trust me when I say, you want to make sure you understand other routes to go with this kind of stuff for things where there's no calculator, like SAT or even just to have a better understanding of this stuff. So if I were to use factoring here, which is going to be actually pretty easy. If I factor this, that's when C is -3. Oops, C is -3. And I want factors that add to -2. That'll just be -3 and 1. So if I were to write this in factored form, I'd have x minus 3, x plus 1. So that means, based off what we learned yesterday with solutions and zeros and stuff, that this graph is going to equal 0 whenever x is 3, because 3 minus 3 would be 0, or whenever x is -1. The reason why that's valuable, so those are my zeros. That's valuable because that means that's where this graph crosses the x-axis. So I know that it's going to cross at 3, and I know it's going to cross at -1. Now, the only other thing I really need to know here is, does the graph open up or down? And since it's positive, since the a value is positive, it's going to open up. If your a value is negative, it would open downward. So I can get a little sketch of this graph like so. And now I can actually answer this question pretty quickly. So when is this graph positive? It's positive here and here. So those are intervals, because again, the question's asking for the intervals. So we're using stuff from chapter 1 here. So this would be anytime x is below -1. So I'd say x is less than -1 or greater than 3. So you can write it with inequalities like that. If you're more of an interval person, you could say from -infinity to -1, or from 3 to infinity. That'd be fine too. So again, 2 ways of writing the same answer. Sorry, there you go. But again, it's tying together factoring to solve or to make the graph with the interval stuff that we did back in chapter 1. All right, here's another example, same thing. So let's go ahead and factor this. So factors of -21 that add to -4 are going to be -7 and 3. And as you do a bunch of these, you're probably going to get to the point where you don't necessarily always need to write it down, which is fine, but you can. So, we'd be like, C is -21, and I want to find the factors that add to -4. So I'm going to use -7 and 3. So x minus 7, x plus 3. And now I know the zeros, because the zeros are what values make these equal 0. So this would have to be 7, and this would have to be -3. So graphically, we have a 0 at 7, 1, 2, 3, 4, 5, 6, 7, and a 0 at -3, 1, 2, 3. Okay, lastly, a value is positive, so this does have to open up. And I don't really care how low it goes. I just care about these values. Because now when the graph's asking me when is this negative, this is the part that's negative, and that's everything between -3 and 7. So we could say it like this, between -3 and 7 using an inequality. Or if you want to do it as an interval, you'd say everything from -3 to 7. Again, either one of those would be a correct way to write that interval. All right, so hopefully those don't feel too bad. That's using factoring to make the graph. Okay, and I am fully well aware that you could graph this, but it's important to understand all these concepts kind of are related. Now, could you graph it in a calculator or on Desmos or whatever? Absolutely. But it's more important to kind of understand how all these things are related. Because again, if you graph this, you can see it's going to cross at the same spots that we just said. So there you go. Same thing. But understand how it works with factoring, because the factoring, the zeros are the zeros. So that's the big takeaway from those problems. All right, so our last one here. Write a equation for parabola that has these x-intercepts and goes through this point. But it does say it wants it in factored form. So factored form is not as common as standard form and these other types of forms and stuff. But factored form, I'm kind of just squeeze it in here, I think makes the most sense. But it's where you have whatever the a value is, and then you have x plus your first factor and x plus your second factor. So it's really you get it in factored form, and if there was any kind of GCF, it's out front. So we've seen this, the 2 problems we just did, we converted them to factored form. That's factored form. That's factored form. So it's where you're getting it into factored form. So in this case, they give you the 2 x-intercepts, which again, remember, these are the zeros. And if these are the zeros, then you can work backwards and come up with what the factors are. Because think about it. Here, the zeros were 7 and -3, and we got those from the factors, which were just the opposites of those. So in our case, if the zeros are at -2 and -1, then the factors have to be at x plus 2 and x plus 1. Because those would be the factors where, -2 would make that a 0, -1 would make that a 0. So when they're giving you these x-intercepts, the zeros, you can come up with the factors. Now, the only other piece to this is the other random point that they give us. So if we think about this, we've got our factored form here. We don't know if there's a number out front, but we can use these to figure out what it would be. Because anytime they give you a point is always just an x and a y value. So you could take this x and this y and substitute them in and solve for a. We've done this type of thing a bunch of different times with other forms like standard form and vertex form before. So if we put these numbers in, 20, we're going to solve for a. We got -3 plus 2. We got -3 plus 1. So again, just put my x in and put my y in. So what does this work out to? We get, that's going to be -1, and that's going to be -2. So -1 times -2 is 2, so you just have 2a. And you divide by 2, and you get today is 10. And so now we can we can write this in factored form. So the factored form would be the a value we just came up with and the two factors we already knew. So x plus 2 and x plus 1. And there we go. Like everything we do, there's always ways to check it. So if you want to check it, you want to check it graphically. So we think this is our equation. If we put this in like so, we could graph it and look for these points, which, if you're using like decimals, that's probably what you're going to do. Or you can go to the table and just look and see if these points are on there. So if I look at, -1 and -2 both should be zeros. Yep. And at -3, it should be at 20. Yep. Looking good. So again, that's just your way to check it out. So if I were you, I would attempt this problem. See if you can do this one. So I'm going to pause it, work it out, and then show it to you. Okay, here we go. So I set up the same way. I looked at my two zeros and I was like, okay, x minus 3 would give me that. X plus 3 would give me that. And then I just set up, y equals a times my two factors. Then I substituted in the x and the y value they gave me. So y was 2 and x was 1. These simplified to be -2 and 4. Multiplied that to get me -8. And then I divided the -8 to the other side. Reduced that fraction to -1/4. So that's how I got my a value. And then I just wrote the answer. So it's the a value with the two factors that I got. So, maybe you're doing this problem and you get a fraction and you think fractions are awful or you can't get them or you think you're wrong because you get a fraction. Just check it. So again, if you want to check your answer here, throw this in the old calculator and go look at the graph, go look at the table and see, are those points on it? So we have -3 is at 0. Yep. At 1, it's at 2. Yep. And at 3, it's at 0. So perfect. Yeah. If it checks out, then it has to be right. So, if you're getting a number that you're not feeling super confident with, just take 10 seconds and check it. Throw in a grapher and take a look at it. Okay. All right. So you're going to have the assignment today, which is just these two types of questions. Then you'll also have the lesson summary, which has types of all the 2-3 questions on it as well. So we got those two assignments today to see how you do.